All right, this is the February 26th study hall. We're going to be doing more word problems along the lines of previous lessons. So we just did the rules. Same difference. Here's the copyright notice again. These are going to be problems from gmatprep, from the free software, copyright GMAT. Cool. All right, let's do a problem. Let's go ahead and jump to a problem on the board. How about that one? Again, remember where you find multiple choice answer options. You find them right there underneath your name. Go for it. All right, we should probably wrap this one up pretty soon, guys. Remember, the name of the game here is if you are not making real progress towards a real goal that is real, then you're done. Also remember, this is a test where you have to answer all the problems. You can't not answer a problem. And you can't skip or return to problems either. So let's pick something. Okay, I don't usually show the answer distribution, but this one is interesting. We have two very sharp spikes. So okay, let's have a quick chat about choice C on this problem. Does anybody have anything to say about choice C? Anybody? No, I'm going with that. Okay, it's too easy is a thing. And then there's also another thing about it, which is, I mean, it does fall into this extremely important category of things that you should be aware of. But first, let's talk about too easy, because too easy is one of those terms that you want to kind of nail down a definition of. So before we talk about this, like if you don't really have a sense of what the GMAT considers like easy or whatever, like if you want to calibrate your sense of too easy, then a good way to do that is just to go to the problems at the very beginning of the official guide. So just, go to the first few pages of problems in the OG math chapters, and then just look through them and get a sense of the challenge level there. And the point is that anything that's substantially easier than that is going wrong. Period. End of story. Because I mean, they do arrange those in approximate order of how many people are getting them right or wrong or whatever. So yeah, let's take a look at if you were to pick choice C on this problem. So yeah, let's just talk about that real quick. You pick C. First of all, it's way too easy. I mean, yeah, of course it is, right? You have all three prices. So if you have that, then you don't need to do anything. You have all the prices, so you don't even have to do anything. But also, just as important as too easy is the fact that it ignores what's in the problem. What I mean by that is this question. I mean, this is a very specific question. And if that's the question, then they're going to want to make sure that you're thinking about that question. This is the goal, right? I mean, because, if you ever watched these sessions before, I'm always talking about how goals are a thing, because one of the biggest reasons data sufficiency is a thing in the first place is because it tests your ability to focus on a goal and make sure that you're actually trying to find that goal. So if you just find all three prices, that means you're not really paying attention to what the question says. And they're not going to let that reward you. Like, they want the problem to reward people who are actually answering the question and to punish people who are not. So yeah, you're not. If you pick C, then you're just finding all the individual prices, and you're not paying attention to the question. So that's not good. Yeah. So I mean, this. Yeah, we have a name. We have a name for this when both of these happen. If both of these happen with choice C, that's a C trap. Don't do it. Here. The rapper Drake will tell you what to do with C trap answers. Don't do it. Don't pick them. I mean, what this means is even if you don't know how the individual statements could be sufficient, you still have to know that the answer is not C. Ever, ever, ever will not happen. Not going to happen. So basically just ask yourself, if you are considering choice C, ask yourself whether these two criteria are satisfied. If they are, don't pick it. Just don't. Because then in that case, it's like playing some fantasy game and you're in the enemy castle and they offer you delicious looking food. I mean, guess what? It's poison. I mean, even if you don't think it's poison, it's poison. Don't eat it. Same kind of thing here. So in these kinds of situations, the answer is not going to be C because C is the trap answer. What else is also not going to be the answer? It ignores the problem. It's ignoring the question. This is a super specific question. This just doesn't say find all three discounts. It says this. It says very specifically, was this thing greater than 15% of those other three things? So the distribution of answer choices, well, they are about 1/5 of each answer. I mean, this is not a large-scale statistical observation. This is just how they write a lot of individual problems. Yeah, it's not going to be E either, because E would mean that even if you had all three prices, you could get it, which of course is false. So you're not picking C and you're not picking E for very different reasons. You're not taking C because C is a trap and they're not going to do that. Not because it's unreasonable. I mean, in fact, it's quite reasonable. It's just how they write trap answers. So that you're not picking because you know they write traps like that. This one you're not picking because it's logically impossible. But yeah, this whole theme of make sure that you answer the question, I mean, this is a very big deal. You need to actually answer the question that is there. And this whole theme deserves a slide of its own before we come back to this thing. Like, if you got to think about the reasons why they have this problem type called data sufficiency, in which you normally don't have to do all the work. This is one of the biggest reasons. So they can ask you a very specific question, and you have to make sure you address that. It's a thing in data sufficiency in general. In data sufficiency, if you don't address the specific nature of the question, you're dead. This is another study hall about word problems. It's kind of a continuation of what we did last time. So let me just give you a couple of examples. I mean, this one here is one example. A couple others. If I ask you what is the 10s digit of the integer n, Okay. You need to actually find the tens digit in particular. If you try to find n, you will never get the problem right. Yeah, same thing. If a question asks you something like, what is x plus y? Well, you need to think about the sum. You need to actually think about this sum combination of x and y. If you try to find x and y individually, you will not get the problem right, etc. I mean, this is the whole point of data sufficiency. They want to give you, because I mean, the reason why this is the point of data sufficiency is that you can't, a multiple choice problem can't punish this. You know, like if you could find all three prices in a problem that was multiple choice, that'd be great. You could just find them, and then you could just calculate stuff. But in data sufficiency, you're in the unique position of being able to punish people who are searching for too much information. That's the thing that you can do. So don't do it. And yeah, C-trap problems, there are loads and loads and loads of them, especially once you start doing better in the quant section, because you remember when they call something a high difficulty problem, that doesn't necessarily mean it's difficult. It just means that a lot of people get it wrong. And these kinds of problems, a lot of people will pick C on these kinds of problems every single time. Okay, so again, this is something you should think about if you are ever going to pick C. I mean, if you do this problem and you get that A is sufficient, then you don't need to think about this issue. But the takeaway that you should get here is if you are ever doing a data sufficiency problem and you are considering C, if you are ever considering choice C on a data sufficiency problem, just ask yourself, is that too easy? And again, if you don't have a sense of that, you can calibrate it as we talked about below. And does it ignore the stuff in the problem? If the answers are yes to both of these things, do not pick C ever. Don't do it, because it's going to be wrong. It's going to be wrong. Both answers are yes, then never pick C or E. So what I mean, do I mean it ignores? I mean, it just doesn't address the question there. I mean, it just doesn't address that. Like, for example, okay, like if you look at me, you can tell that I am very obviously over 21 years old. So if the question is Ron over 21? You can tell that by looking at me. You can't tell how old I am from looking at me, but you don't care. Same kind of thing, because that's not the question. The question is not exactly how old am I. I don't quite understand the part about supplanting stuff. It's a bit abstract for my brain. I don't really get what you're asking there. But the point is that if you don't have to actually answer this question, then that's bad. You need to be thinking about that. Same thing here. If this is the question and you're not thinking about digits, that's bad. You have to think about digits. If this is the question and you're not thinking about x and y together, that's bad. And that's, Sam, that's basically the idea behind E. I mean, E would mean that even if you had all the prices, you still couldn't do this. Well, I mean, of course you could. So let's talk about actually solving this thing. But this is super common. In fact, a good exercise to do is to go through your official guide and to look for all of these that are C-traps. I mean, after you get past number 100 or so in the data sufficiency chapter, something like 20% of all the problems are C-traps. So definitely worth looking for as a thing. Okay, here's the problem that we are on. Here's the problem. Okay, so let's say that this question is sort of awkward. What do you want to try to do when a question is awkward or like unnecessarily bulky? Yeah, you want to try to simplify it, right? Because it's just cumbersome the way it is now. So, I mean, you don't want to just try to, like, change questions randomly. But in the case of a question like that one, where it's like, why is it so weird, right? So if you, yeah, you want to, let's try to simplify the question is basically the point. So let's say that E is the price of the expensive item. And let's say that M is the price of the second most expensive, so the medium price, middle price. And C is the cheap price. And these could be the same as each other too. I mean, there's nothing prohibiting the prices from being the same. So like E and M could be the same number, for instance. But okay, so then the discount is 20% off of E and 10% off of M and C. So the total amount of the three discounts greater than 15% of the sum. Okay, well, total amount of the discounts, you have 20% of E, and then you have 10% of the others. Was that greater than 15% of the sum of all of the prices? So this is what the question literally says. But again, this is something you can definitely simplify. I mean, so if you decide to go the algebra route, this should just be an instinct that you have to simplify this. I mean, this is not the kind of thing that you should have to think about simplifying before you simplify it. You should just simplify. Don't think about it. You shouldn't have to think about it. I mean, simplifying this, you should think about it. Oops, lost my microphone. You should think about simplifying this the same way that you would think about simplifying. Like if you had 10 halves in the problem, you would just call that 5. You know, no matter where it was. Doesn't matter if it was in the question or in one of the statements, you wouldn't care, right? If the question was like, is Ron more than 80 halves of a year old, you would just make that 40 years, and then you would start thinking about it. So, in other words, think about this the same way. I mean, think about this simplification. It should be automatic. It should just happen in the same way you'd pretty much automatically change like 20 halves into 10. Definitely should be automatic. Okay, so if you simplify that, let's see. I mean, we can bring, this is 0.15 of each of these, right? So we can bring that over here and make that positive 0.05e. And then we can bring these both over there, and that leaves you with 0.05 of each of those. And then you can factor out the 0.05. So there's your real question. Oh, that's much nicer. That's the real question. And again, if you have this instinct to simplify this, then there you go. So yeah, I can make that darker here. Let's make that. That should help. Okay, the simplification should be automatic. It should just happen, is basically what that part of the text says. Okay, well, this is a yes-no question, right? So remember the protocol when you have these kinds of things. First, get rid of the words yes and no. Yes means E is greater. No means it's not. So the point is that you're trying to get both of these kinds of things. If you can get both of these, then that means not sufficient, is what that means. Get both equals not sufficient. So that's what we're trying to do with each statement. See if we can get both of those to happen. So there's this protocol that you can set up just to keep your goals in mind. So one way you can set this up on your paper, just to remember what the goal is to write these both down. Really, you should do this. It helps to be able to look at both of them with your eyes. And one way to do it so that you don't have to keep writing the same statements over and over again is just to make those basically columns. Those are rows. And then for statement 1, you can have a column. For statement 2, you can have a column. And if you have to combine them, you would have a column. The point is if you can make check marks, if you get 2 check marks, then that's not sufficient, right? If you have 2 check marks in the same column, means not sufficient. Okay, that way, you know, this is an efficient way to keep track of this. Okay, well, statement 1, we know that E is 50. So let's take a look at E versus M plus C. So E is 50, M is 20. What do we know about C? We know that it's 20 or less, right? This is 20 plus something that is less than or equal to 20. So, Emily, that looks like what we did up there. Did you just log in? Maybe did you just get here? Because that was the question we originally wrote, and then we simplified it. And we got this from simplifying it. I mean, okay, so this is 20 plus at least, or at most 20. So 20 plus at most 20 is at most 40. So, well, if you think about that, can you get this to be greater than that? Well, sure you can. Put a check mark in that box. On the other hand, you cannot get 50 to be less than or equal to something that is smaller than it. So this is impossible. And this is sufficient all by itself. So if you got this on your first pass through, then you don't need to think about the whole C trap thing. But if not, then you would definitely want to be second guessing if you were thinking about C here. Statement 2 only tells you that the least expensive item was a certain dollar amount. So E, M plus C, well, if we think about this, this has to be 15. Those other two could be anything, right? So we can just pick cases that show. So like if M is, I don't know, 20 and E is 100,000, then that's greater than. But if M is, say, 20 and E is 25, then it's not greater than. So we can put check marks in both columns this time. And this is not sufficient because they made both of those things happen. Is it like a weighted average problem? No, I don't know that it really is like a weighted average problem, at least not in a trivial sense. Because you're not talking about the actual value of 20% of something plus 10% of something else. I mean, if you were thinking about how big that was, then it would be sort of like a weighted average problem. Although, well, if it was weighted average, you wouldn't be dividing by 3. In fact, dividing by 3 would be unweighted average. That would just be the average of 3 individual quantities. But in any sense, this isn't really a weighted average problem, at least not in the sense that you can use any techniques that are developed for those. So, but yeah, statement 1 sufficient, statement 2 not. So this is A, alligator. But perhaps the most important general takeaway about this problem is that you should not pick C no matter what. You should be like, dude, they're just giving me all the prices. And this is not really how life works. So, yeah, okay. Are there any questions about the stuff on the board? If you didn't want to do algebra, I mean, well, what's the other major way to do data sufficiencies besides algebra / textbook methods? What's the other major way? Yeah, you can test cases, right? So we can do that here too. I mean, if you leave the question the way the question is, then you can test cases. So let's try that. Because again, the point of testing cases is to not really do algebraic manipulation. It's just to use the statements exactly as is and just to throw numbers in them. So, all right, so the question is basically, well, so we have an expensive price, we have a medium price, we have a cheap price, and then we have 20% of that plus 10% of that plus 10% of this. And the thing that we're comparing that against is 15% of the price of all of them. Okay. And making columns like this is a very good generic way to set up any testing cases at all. So regarding the question in the box there, I mean, again, if you have a sense of too easy, I mean, just take a look at the first few pages of problems in the OG, because that's how the first few problems, they still are nowhere near as easy as, let me just hand you 3 numbers. I mean, they don't do that, right? I mean, even in the first, like even in problem number 1, you still have to think about absolute values and signs and stuff. So again, if you're picking C here, then that's just like, dude, I have 3 things and that's what I have and I'm done. Because anything they ask me about 3 definite values is not going to go both ways. So, I mean, it should be clear that that is much easier than anything they would ever give you. So, let me know if that makes sense. You don't even think about difficulty level to realize that. Smiley face if you are the person who wrote that question. If that makes sense. Okay. I mean, maybe you're making it too complicated. Because again, picking C here means, look, they gave me this, they gave me this, they gave me that. So the answer to this will either be yes or no. I don't have to do any work. They're not going to do that. They're just going to hand you all the stuff. Okay. Testing cases. All right. And again, we can take our same apparatus for whether the statements are sufficient or not, where you just write the possibilities down like that, and then columns for the individual statements, just to keep track of the goals so you can look at them with your eyes. That always helps. Remember, 2 check marks means not sufficient. All right. Statement 1, okay, like we have an E, an M, and a C. The E is frozen at 50 and the M is frozen at 20 by statement 1. That's the point. The point is that you can answer anything, and so you don't need to think about the particular, very specific question they are asking. That's the point. Yes. Okay, what kinds of values do you think we should test there? Considering this is a problem, yeah, it's a problem about inequalities, right? So testing extremes, because if you're going to get an inequality that have two different behaviors, you're going to do it by testing the different extremes. So yeah, it's a good way to do it. So we want to try it with the cheap item being free, and then we want to try it with the cheap item costing $20. If those both turn out the same way, then we can pretty much just trust that it's going to happen the same way every time. So if we do this, that's going to be 20% of 50 is 10, plus 2 plus nothing is 12. And this is 0.15 of 70, which is 7 plus half of 7. That's greater. So I put a check mark in that box. This is 10 plus 2 plus 2 now. And then this is going to be 15% of 90, which is 9 plus half of 9. Still greater. And again, these are linear inequalities, so they're not going to do any funky behavior in between these two. Like if it's greater on both ends, it's going to be greater between all those points too. So this is not, you're not going to be able to get this to happen. This is impossible. So this is sufficient. You only have one thing. For statement 2, you have complete freedom to choose E and M. This just has to be 15. So in the interest of being sort of lazy, we can always just use the same type of numbers that we had up there for the first case. I mean, if we have 15 and 20, then we know these are 10 and 2. And then this is 1.5, so that's 1350. And then this is going to be 0.15 times 85. Well, that's going to be less than 1350 because if you look at the case on top, it was 1350 for $90. So I don't even care what it is because I know it's less than that. All right, once this happens, what is our goal? What are we trying to do now? We're going to try to get a less than or equal to there, right? So if you notice, how are you going to do that? Well, I mean, you could just test random extremes like prices that are really close to each other and then prices that are far apart, and that would work. Although if you want to be strategic about this, you can notice that the expensive item has a stronger impact on that one. So if you make that smaller, then that's going to give you a better shot because this is the one that pulls the left-hand side up. So if we make that, you know, something that's like if we make that also 20, because then we're trying to minimize the effect of that. So then this would just be 4 plus 2 plus 150. That's 750. This is going to be 0.15 times 55. That's 550 plus half of 550, which is going to be more than 750. So that's, you don't have to calculate exactly what that is because half of 550 is more than $2. So we got that to happen. Check them both. Not sufficient. That's A, alligator. How about that? Cool. I mean, notice if you didn't think of this, if you didn't strategize this much, you could just test extremes. You could just be like, okay, well, I did it with this being pretty big. Now let me try it with that being small. You know, that's kind of how you do it. So can't you use one equation? No, you can't because it's an inequality. And there are also a couple of other inequalities inherent in there too, because if you call them expensive and less expensive, then those are like having more inequalities. But yeah, no, long story short, you can't. And you could tweak these so that something like number 2 could be sufficient, depending on how you did it. It doesn't say that they are different prices. Like if I bought 3 things that all cost $20, then the most expensive item is $20, and the least expensive item is also $20. I mean, think about if you go to a store and it says, here's a coupon that takes 20% off the most expensive thing. If you have 2 that have the same high price, then they'll just take 20% off of one of those. So, I mean, if you do that, it'll still work. I mean, if you guys are afraid of that, then you can just pick 21 where we have 20, as Christina is saying. Sure, I mean, you can do that. But you don't have to. I mean, unless it specifically says they have to be different. They don't have to be different. So, but they're not going to make problems that depend on that. They're really not going to. I mean, I've never seen a problem where the answer changed if you had to worry about that. Because again, that's not really how these guys, I mean, remember these guys are not tricky and they are not nitpicky. And it would be against the ethic with which they write these problems if they did that. So you can pretty much rest assured either way. But as far as the ease of testing cases, I mean, you don't have to make this not equal to 20. All right, cool. Any other questions about this one? No, let's do the other one. Let's do this one. All right, let's kill this one shortly. Alex, Ellie, Abhinav answers. This is interesting. I mean, here is the response profile. And interestingly, the correct answer to this problem is not actually E elephant. So we'll get to what it is in a second, but very interesting, considering that was the response chosen by about 2/3 of everybody who actually answered the question. But yeah, first, okay, all this stuff about time. I mean, I don't show a timer on the screen. Yeah, the audio is on. Yes, yes, it is. You guys can hear me, right? Okay. All this stuff about timers. Okay, just remember. All right. I mean, let me tell you a story. Once upon a time, there was a student who just was working on a problem, and who looked at the timer, and then he looked back and started working on the problem again. You know what that story's called? called a fairy tale. You know why? Because it doesn't happen. I mean, if you look at the timer, there's this whole chain of thought processes that you cannot avoid kicking into action. Like when you look at a timer, it's not just I look at a timer. It's like I look at it and I subtract times and I calculate things and then I like stress out about it and then I recalibrate other timing and then I stress out some more and then I have to try to refocus. And then after all that, you get back to work. I mean, this happens. This definitely happens. And so every time you look at the timer, you are obviously costing yourself probably between 15 and 30 seconds for this whole process. And I mean, there are some people who would look at the timer every single problem. I mean, if they're doing that, that means that you are probably spending 10 to 15 minutes. Okay, I mean, here's my suggestion about this. It's not the same as what's in the books, but it's just kind of a more pragmatic type of thing. Okay, first, during the first half of each section, don't look at the timer at all. Don't do it. Because there's no point. I mean, if you are like 1 minute behind the average and you are only 1/4 of the way into a section, it's not like you're going to do anything about that. I mean, that's way too early to start making adjustments. So the point is, if you look at the timer at all during the first half, it's kind of just a waste of your time because you would be doing all that listed above for absolutely no reason at all, right? It's way too early, way too early to make adjustments. So really just a waste of your time. Okay, and I mean this implies, of course, all of this implies that you should hide the timer, definitely hide the timer, hide it all the time. Do not leave it on the screen. Don't do it. I need to make sure that going too fast shouldn't really be too much of an issue. But I mean, yeah, don't do it. I mean that sense should be internal. That should be self-discipline. It shouldn't be I need to look at a timer all the time. And then I would say, you know, just look at it maybe, I don't know, halfway through and then 3/4 of the way through. That's it. And then also the other major fault of most of these timing charts that I see is that they're dividing up the entire time period, which is like planning to have 0 minutes left at the end. I mean, that's the other problem. Like, you really don't want to be up against the wire. You really don't. So, I mean, you should plan your checkpoint times with, like, I don't know, 5 minutes at the end of time cushion. Just because you should. I mean, this is how you plan anything. Like, for example, my wife watches this reality TV Netflix show called, like, Ink Masters. And it's about these tattoo artists who get exactly 6 hours to to put a tattoo on their client. And I mean, the point is they don't plan to use all 6 hours. I mean, think about what you would think if they took all 6 hours. You would probably think, oh, they didn't really finish, and they had to like really rush it at the end. You know, they plan to take 4 or 5 hours or something, and they have that period at the end in case something goes wrong. Same sort of thing. So like, for example, for Quant, I mean, basically all the time you need is you just have 2 checkpoints. So at, like, let's say the start of number 18, which would be or start of number 19, which is the halfway point, there's about 40 minutes left. And then at the start of halfway between the 3/4 point would be like halfway between 19 and 37. So yeah, like 25 minutes. And this is really kind of it. So much, 75, 30, about 22 to 23 minutes. That's it. That's all the timing you really need. If you have to look at it more often than that, then lack of self-discipline. Shouldn't have to do it. But definitely don't show it while you're working on the problems. If you're doing the raised hand thing, just type your question in the box, please. Yeah, well, I mean, on the longest problems, you may be justified in doing that, but you don't. The internal clock is not a clock. It's not. It's not thinking about minutes and seconds. It's being honest with yourself about whether you are still making any progress. Okay, so like this is not the right way to think about it, because you don't need to think about minutes and seconds. That's not what the thought process is. Not the right way to think about it. I mean, basically, time management is really just a couple of things. I mean, this is all you need to know about time management right here. All you need to know about it is you need to be honest with yourself about whether you're actually making progress. Be super honest with yourself. Am I making real progress toward a real goal? That's either a yes or a no. If it's no, you should stop doing what you're doing and try to do something else. First, try to find the goal. Try to reorient yourself. If not, look for a different method. And if not, move on with your life. So, and then don't do the same thing more than once. So if you try algebra and it doesn't work, don't try algebra again. I don't know what a round timer is, so that I don't know what that means. And I mean, again, but 2 minutes is not really a meaningful thing on an individual level. I mean, that's just an average. Like, you wouldn't plan to finish a problem like this in 2 minutes because this is a long problem with lots of words. I mean, that's not a good way to think about it. So, and you should never spend 8 minutes on a problem. I mean, what? That means that you've been, if you're spending 8 minutes, that means the answer to this has been no for a very long time. I mean, okay, if you like thought experiments, here's a very good thought experiment for this. I mean, and if you can really sink yourself into this situation and imagine that it is real, then you will immediately have perfect time management. Here's a thought experiment. Okay, you're in the GMAT and you have to pay $100 for every step that you do, including steps in your head. For every second you spend just staring at the screen or at your notes. That's $50. Okay, if you get the problem right, you get all the hundreds back. Plus, to actually give you an incentive to take this, let's say, plus another $300 on top of that. But you never get the 50s back. 50s are gone, are forever. You never get them back. Okay, if you can think about this thought experiment, if you can imagine the habits that you would have under these circumstances, then you will have absolutely perfect time management and you will not need to think about anything else. Because if you were actually paying out $100 for every step that you did, just think about when you would do steps. You would only do them if you were pretty darn sure that they were actually headed towards a real goal, because otherwise you're just wasting hundreds of dollars. You would also not spend any seconds doing this because that's really expensive. So, if you can imagine this situation, whatever habits you would have in this situation, you should have on this test. And if you do, that would be instant, perfect time management. Just as long as you can imagine this situation in your head. Same habits you would have here. So just ask yourself whether you're still paying $100 a step. Yeah, it's a little bit, yeah, obviously it's a very far-fetched situation, but Sam, you need to not look at the time, because again, every time you look at it, this is what's going to happen, and you can't really afford to do that. So just don't do it. Just practice without it. Get used to it. I mean, if it's practice questions, I mean, it depends, right? If you're doing a set of word problems, for example, that would be a very bad idea, because word problems tend to be longer than average. So, I mean, I wouldn't really stress about it, because remember, time management is just this. This is all that time management is. So if you are doing this when you practice, then you don't need a timer. I mean, because honestly, you really shouldn't need one anyway. I mean, a timer should be a formality. You should have good habits like this. And then even if you didn't have a timer at all, you'd still be all right. I don't know what you mean by going around. Going around. Not sure what that means. I mean, again, that shouldn't happen, basically, because, like, okay, here. Let me make stupid analogies for this. Here are two kinds of things that people might make contingency plans for in life. People ask questions like, what should I do if there's an earthquake? People should say, what should I do if I max out all my credit cards? Okay, these are not the same, right? Like, this is worth making a plan for. Okay, this, though, the best response to this second question is just don't do that. Because this is under your control. And there are actually studies that show that if you make plans for situations like this, then you are more likely to let them happen. Like if you actually have a plan for what do I do if I max my credit cards out, that actually makes you more likely to max out your credit cards out. So, I mean, with regard to this kind of thing right here, same thing. The best response is just don't do it. And don't make a plan for it, because just don't do it. Same as this. Just have good time management. So, yeah, I mean, you really shouldn't have to look at the time at all, is basically the point. I mean, it should be a formality. It should be a thing you don't really have to do. So, I mean, if you're a few minutes behind, then you can adjust, is the point. But, yeah, you really shouldn't have to. So, Sam, still the same thing, still $100 a mental step. And $50 a second staring. Just ask yourself, what am I doing right now? Why? You know, explain. Make yourself explain what you're doing. Like, try to talk out loud through problems. This is another thing. I mean, if timing is really an issue, like, actually pretend that you are recording a video of the problem and explain what you're doing at all times. Because if you cannot explain what you're doing, that means you're stuck. How about that? You should just be able to talk through it. If it's a verbal question, you should be able to say, what words am I looking at and what am I looking for in those words? If you cannot articulate what you are looking for, then you're probably stuck. So, yeah, you shouldn't have to skip questions either. You shouldn't have to do any of these things. You should just have good time management habits. So, all right, let's talk about the problem board. Let's talk about this. Because again, most people pick E here, and the answer is not E. So let's talk about it. So basically the only thing you have to know about business for the GMAT is that profit is revenue minus cost. Okay. So that's revenue up there. So in this case, profit is 500,000 minus cost. Okay, so was profit greater than 150? You can also ask the question of, this is the same question as, was cost what? What could go here? Yeah, less than 350. I mean, there's two ways to arrive at that. The first would just be to kind of think intuitively about, because you have a total of 500,000. So if this component is more than that, then this component has to be less than whatever's left. Or you can also just do algebra. You could say like profit is greater than 500,000, which means that is 150. Which you could write that algebraically as 500,000 minus C greater than that. And then you could subtract 150,000 and you could add C. Same sort of thing. So, or you just think about it either way. So this is the deal. So you can make, either one of those would be like a yes. So you can make your little grid of possibilities again. So profit greater than 150, which is the same as cost less than 350. That is a yes thing. Or you could have profit not that, and you could have cost, which would correspond to having cost greater than or equal to. And you can think about whichever one of these is convenient to think about. I mean, you don't have to think about the same version each time. And then you can, for each of the two statements, and possibly for the two statements together, see if you can put check marks in there. So statement 1, statement 2, and then if we have to put them together, if we have to, if necessary. Okay. We might not have to. We might. We'll see. 2 check marks means not sufficient. Okay. And cost breaks down to labor plus materials, and that's what it is. So this is the cost is 3 times the cost for materials. Remember, cost is labor plus materials. So labor plus materials is 3 times materials. So you have that labor is twice as expensive as materials. The problem is that you don't know what these are. I mean, it could be the case that labor is $2 and materials are $1, and so the cost is way under this. Or labor could cost, materials could cost 150,000 and labor could cost 300,000, and the cost could be more. So both of these are going to be possible. And if you want to make a table of cases to make that more clear, you certainly can, right? So you could say material, labor, total cost, and then the share, right? So you have this 1, 2, 3. 3 is definitely less than 350,000. And then if I have something like 150K, then that's 300K, so that's 450K, which is greater than that. Okay. So that's both. What about statement 2? Well, where's the problem with statement 2? Yeah, it doesn't relate to materials, so, and if you're still not sure how it's going to interact, then you should test cases. Like if you could have labor cost, I don't know, like $100,000. And then you could make a column for profit this time too, just to make sure that you are keeping in line with the statement. So let's make a column for that. Okay, so then if materials are free, if you're like recycling everything, then this would work. So that's a profit of greater than 150,000. But then notice we still need to keep the profit greater than the cost of labor. But if we, like, let's say, we could make this so that it's 101K, and that's still 100K. We could just figure out the appropriate numbers. If that's 101K, then the cost would have to be 399K, which means that would be, what, 299K. That's what works. So this is less than or equal to 150,000. So these are both possible. All right, now let's put them together. Let's do that. So together there's a lot of conditions. It might be annoying to pick cases here, but it might not. We'll see. So we know that L is 2M. So the total cost is going to be 3M, which is the same thing as 3/2 L, which is the same thing. Yeah, that's what the cost is. Either way you want to figure that out. Probably better to do this because labor is in the other statement. So the profit is greater than the cost of labor. So that means 500,000 minus cost is greater than labor. So 500,000 minus that is greater than L. That means that 500,000 is greater than 5L over 2. Double that first, and then divide by 5. So yeah, labor costs less than 200,000. At this point, what we can do is now we can test cases here because now we have a concrete ceiling on the cost of labor. So if this is like risk, it can't technically be 200,000, but it can be very close. It can be like 199,999. Then materials are going to cost half that much. Notice we're testing extremes again. This is the top extreme. So then the cost is about 300K. And the profit is about 200K. But wait a minute, make sure you think about which side of the, you don't have to think about which side this is. Like technically this is a little bit under 200K, so this is a little bit over 200K. But it's definitely more than $150,000. So sure, we don't even need to think about the marginal difference there. This is more than 150,000. The other extreme would be labor is basically free. So then materials are also free. And again, if you don't like saying that 0 is twice 0, then you can just say these are very close to being free, but not. So this is, a small number, epsilon, it's approximately 0. Then your cost is almost nothing, and your profit is very close to being all 500,000. So that's greater than still, both extremes. So you can get that. These should actually be greater than signs. You can't get this though. This is not happening. This is impossible. And so it is sufficient together. This is C like cat. This one, I mean, this one is a little bit, you really have to keep track of your goals. And I mean, almost 2/3 of this group said E as their answer here. And I mean, there could be different reasons for that, but I would strongly suggest that the most important reason was simply not keeping track of something like this. You really need to have the goals written down somewhere, because otherwise you will definitely forget what they are. So you don't have to make a matrix of possibilities exactly like this, but you could solve for M, and then you would just have to translate this one. So you could write this as cost is greater than 2M instead of cost is greater than L. So yeah, you could do that. Sure, you could, if you don't want the fractions. So that is doable. You should wind up with M is less than 100,000. I mean, here let's just look at that. So let's express it as cost is 3M. Okay, let's just see what happens. So the difference would be that you would have 2M here instead of labor, and you would have 3M there. I think maybe you know what the fix is for that, right? I think you subtract it instead of adding. The fix is, let's go back to first grade and make sure that we show all our work. Yes, let's make sure we do that. I mean, really showing the work, it sounds like it would be crazy if that was what's responsible, but that is absolutely what's responsible. So there you go. N is less than 100,000. And then it's the same extremes from there. So if you had M and 500,000, it means you subtracted 3 and 2 instead of adding them. That's what that means. If that happens, the fix for that is easy. The fix for that is just show the steps every time. Just do it. Yep. From statement 1, you can get that, although notice that this is a stronger criterion. So, and actually you can. I mean, in statement 1, there's nothing prohibiting cost from being greater than revenue. I mean, you could have cost in the millions and just make a huge loss on the project. Because we don't, you know what I mean? Like, cost is not, I mean, people make negative profits all the time. So they're probably not going to make the problem do that, but you can't have cost at 500,000 here, which is up and up. That looks like what you're doing there. So we can approximate labor to be if, well, I don't know which statement you're addressing there by doing that, maybe. So, but something is not right if you think that statement 1 is sufficient, because statement 1 is not sufficient. See what you're typing. Okay, well, I guess you're still typing. What does that mean? Yeah, so that just gives you this. Right. We have that. And then Oh, I think I know what you're doing. Yeah, that's the question, right? I mean, so this is, I think, okay, this is the problem. I mean, at least what you wrote here. I mean, you can't make a statement like this because that's not a fact. That's the question. I mean, you can't, if it's okay to do algebra with the question, but if you're going to do algebra with the question, you have to leave it as a question. Like, notice you absolutely have to keep this word here and keep this piece of punctuation, and keep this word and keep this piece of punctuation. Because otherwise, like, it looks like you're using those as though they were facts. Right? You're saying we can approximate that L is that. No, we can't, dude. That's a question with a question mark. You know, like if someone asks, is Ron over 50 years old? Question mark. You can't suddenly go around assuming I'm over 50 because that's a question. It's not a fact. So just keep that in mind. Just make sure you keep the border between questions and statements bright line. Don't confuse those with each other. Okay, let's see. Well, we don't really have a ton of time here. Let me think if there's anything we can do in such a short amount of time. These are all word problems that I've collected here. They all take way longer than that. Let me think about this. Yeah, I don't have any other problems in these slides that we can cover in 3 minutes. But let me see if I can pull something from another file. All right, here, let's do this. This one is cool. This is not a word problem in any real sense of the word, but, you know, hey, try it anyway. Okay. In the bottom half of the screen, I'll address this. You can do this. There, that's algebra. Okay, let's kill the time for this one. So yeah, all right. My point with this one is, what should you do if you don't immediately know how to do the exponent fund? And if you know how to do this with exponents, well, that's great. I mean, you know, the way to do it with exponents is to be like, okay, that's 2 times 2 to the 5th plus 3 times 3 to the 5th. Because, you know, like there are literally 2 of these, and there are literally 3 of those. But then that's the same thing as 2 to the first times 2 to the fifth plus 3 to the first times 3 to the fifth. So then that's 2 to the sixth plus 3 to the sixth. Okay, that's fun. If you don't think of this immediately, what should you do? You should just do it. You should just pick up the shovel and dig. If you don't think of this right away, pick up the shovel and dig. You know, no, you don't even need to really approximate it because, I mean, this is not really that much math. I mean, I've actually had students tell me, like, with a straight face, I think it would take 5 minutes to do that. Do you really now? No, you don't. I mean, okay, 2 to the fifth is 16 times 2 is 32. Right, this is 32. That's 32. And then 3 to the fifth is 3 times 3 times 3 times 3 times 3. That's 9 times 9 times another 3, which is 81 times 3. That's 243. Okay, that's not so bad, right? So we have 32, 32, 243, 243, 243. That's really not very hard. Okay, well, 3, 3, 3, 2, and 2 is 13. So add a 1. That's 13 plus 6, 9, 693. No, it's bigger than that. 793, looks like. Okay, and I mean, you guys are faster at arithmetic than I am because I know that I'm really slow at arithmetic. So the answer we want is 793. I mean, some of these things, common sense, guys. I mean, like, 3 of you guys picked B, but like, really, 13 to the fifth? That's big. That's really, really, really big. I mean, 10 to the fifth is 100,000, so 13 to the fifth is even more than that. Like, whoa, way too big. 5 to the sixth, well, you might, this is 25 times 25 times 25. I mean, 25 times 25 is already 625, and then times another 25 is way too big. Or you can just think about 20, 20, 20 would be 8,000, and this would be more than that. 4 to the fifth plus 9 to the fifth, if you just think about the 9 to the fifth alone for a second, I mean, this is ginormous, right? This is 81 times 81 times 9. I mean, 81 times 81 is already more than 6,400, so this is way too big. And then you can also do last digit. Yeah, you can do that too. But like 3 to the 8th is the 3 to the 8th alone is, again, that's 3, 3, 3, 3, 3, 3. That's 9 times 9 times, that's 9 times 9 times 9 times 9. That's 81 times 81. Well, that's still more than 6,400. Way too big. Oh, they're all way too big. Except for C. I guess we win. So yeah, that's doable. You can also use it. You can also do the digits that Abhinav is talking about. That's a way to approach it as well. But I mean, this is the point, right? The point is this. Do not talk yourself out of doing things. And don't guess how long stuff will take. I mean, don't do it. Because you're not going to guess right. Like, people are terrible at guessing how long stuff will take. I mean, the first approach is pretty, and it's cute and elegant and whatever, but if it's not there in your head, then it's not there. Let me leave you with a suggestion. In your OG, let me make sure I've got the right problem number. I can't put it on the board here because it's an OG problem, but I think I've suggested this one before, but yeah, okay. OG multiple choice number 199. It's on page 180. Try doing it. with old-fashioned arithmetic. Because that's the one problem where people are like, oh my gosh, I think that's going to take like 10 minutes. But really, just do it, just try it, and see what happens. And then you can take a lesson there about it. Because I mean, they really do engineer these problems so that you can pick up the shovel and dig. They really want to make sure that you can do that. Okay. Wait a minute, let's see what this question is. We got to close up shop here pretty soon. Here's the problem. I mean, remember the way we set this thing up. I mean, here was the mechanism. I mean, this is not, make sure you know how data efficiency works, right? I made this little chart of, I remember what these rows represent. These rows represent yes to the original question. And this represents a no to the original question. You just don't want to keep thinking about the words yes and no because those are not math things. I mean, you can't do a bunch of math and have the word no pop out of it, right? So, I mean, if this is one of those basic understanding of data sufficiency things, but if you get that this is definitely greater than 200,000, well, this is profit. Profit is greater than 200,000 is what you find. You don't find that cost is greater than that. You find that profit is greater than that. Maybe that's the problem. But if you find this, then that makes this impossible. And that means that the only possibility is this. So that's the definition of what sufficient means. It means that you only get one of those. But if you go back and look at the work that we did, I mean, it's not the cost that's greater than 200K, it's the profit. So you might want to just look over that again. All right, we got to wrap it up. But since we only did 2 problems today, we actually have more of these that we can do next time. And so we'll do that. I mean, if there's any danger of forgetting what the goal is, then you should write it. I mean, in these yes/no things in particular, I mean, it's a very weirdly abstract goal in the first place. It's like making 2 different things happen rather than solving for something. Because you're not solving for something, and that's one of the principal challenges here. Is a lot of people have never really done math problems where you don't solve for things. But here you're not solving for a thing. You're like trying to make 2 possibilities obtain, which is weird and different. That's why this helps especially here. But really, if there's any danger of forgetting what the point of what you're doing is, then just write it down. That's the lesson now.